Let's look at x equals 1. Now I need to look at the limit as x goes to 1, sine of pi x over 2x squared minus x minus 1. So once again, I substitute in the numerator. Then I get the sine of pi, and the sine of pi is actually 0. And in the denominator, I also get 0. So I have a 0 over 0. And remember, that's an indeterminate form. The limit may actually work out. The limit may actually not work out. But if it's 0 over 0, at least I have a shot in doing some sort of maneuvering. Okay, so let's try to rewrite this then. I know how the denominator factors. It's 2x plus 1 times x minus 1. And the troublesome factor in the denominator as I get close to 1 is this guy here. Okay, so I would want to try to group that. That's the 0 in the denominator, with what's going on in 0 in the numerator, and try to get that to work out. Now, if we think back to class the other day, we know we have this property. As u goes to 0, the sine of u over u equals 1. And what you really need for this to work is you need what's inside the sine function to match what's going to be on that denominator. So what our challenge is to see if it's possible to take sine of pi x over x minus 1 and rewrite it into some form of this or some constant multiple of that. Well, the first thing that we need to do is fix up the coefficient on the x. Here it's pi x, here it's just x. We've seen how to fix this up before. I'm going to multiply the numerator and denominator by pi. And when I multiply that denominator by pi and distribute it, I'm going to get that. So these two fractions are the same. I can factor the pi out of the denominator, cancel it out. I haven't adjusted the value of the fraction at all. Well, now I need to get what's in here the same as what's down there. And so I'm going to make a u substitution. I'm going to let u equal pi x minus pi. And so if I look at the limit as x goes to 1, that's going to happen exactly when u goes to 0. So x goes to 1 happens exactly as the u goes to 0. So that's going to set me up good for that. Now let's see then what this turns into. I have that pi. I got the u now on the bottom. What's the inside of that function going to look like? Well, I know I have sine of pi x. Well, from this equation I can rewrite this as u plus pi equals pi x. And so what I have up there is sine of u plus pi. Now these aren't quite the same thing, but thinking back to trigonometry, I can simplify that sine of u plus pi by expanding it using the sum rule. So the sine of u plus pi is the sine of u cosine of pi plus the cosine of u sine of pi. The cosine of pi is -1, so I have negative sine of u. The sine of pi is 0, so that whole factor zeroes out. So what do I get? This is equal to negative sine of u. So I'll put the negative out with the pi, so I get negative pi sine of u over u. So what's this mean? The limit as x goes to 1 of sine of pi x over 2x squared minus x minus 1 is the limit as x goes to 1 of 1 over 2x plus 1 times sine of pi x over x minus 1. As x goes to 1, the 1 over 2x plus 1 goes to a third. As x goes to 1, the sine of pi over x is the same as negative pi sine of u over u as u goes to 0. So this goes to negative pi. So what's my grand final answer? Negative pi over 3. So the limit does in fact exist. And since the limit exists, that means that x equals 1 is a removable discontinuity. So how do I remove it? Well, here's how I remove it. I'm going to make f of x a piecewise defined function. I'm going to make it sine of pi x over 2x squared minus x minus 1 when x is not equal to negative a half or 1. And then I'm going to define it to be equal to its limit, which is negative pi over 3 when x actually equals 1. So that'll do it for number 2. Alright, number 3, the cost in dollars to remove p% of the invasive Ipazuti fish from Sasquatch Pond is given by this formula, where p is between 0 and 100, less than 100. We're asked to find and interpret the limit as p goes to 100 from the left of c of p. Alright, so first we need to find that limit. So to find the limit means we do the mathematics. Let's take the limit as p goes to 100 from the left of c of p is the limit as p goes to 100 from the left of 1770p over 100 minus p. First thing we do is we see if we can substitute. I plug 100 into the numerator. Oops. I get 1770 times 100, which is 177,000. On the bottom, I get 0. So I have the limit does not exist. I'll just put it that way. But since it's a one-sided limit, I might be able to figure out exactly how it fails to exist. So, when I'm coming into 100 from the left, I'm thinking of plugging in numbers a little bit less than 100 minus something. So I'm thinking of plugging in numbers like 99.9, 99.99, etc. When I do that, okay, the C of P here, I keep wanting to put 11d7. Well, the numerator's still getting close to 177,000. But what kind of number am I getting down here? Well, as I'm sneaking up to 100 from the left, I'm plugging in numbers that are smaller than 100, but just by a little bit. So this becomes a very small but positive number. And the result of a small positive number divided into this number is going to be a very big positive number. And the closer I get to 100, the bigger that number is going to be. So that's going to become unbounded, and we actually write that then as infinity. So what we would say is that the limit, as p goes to 100 from the left, of c of p equals infinity. The limit still doesn't exist, but it's a little more precise way of explaining how it doesn't exist. So that's the find part. What's the interpret part? Well, what's it mean in this situation? P represents the amount of the Ipazuti fish we've removed from the pond, and C represents the cost in dollars. So P approaching 100 from the left means we're trying to remove all of the Ipazuti fish. If we try to remove all the Ipazuti fish, how much is it going to cost? Infinitely many dollars. So what that really says is it's impossible to remove all the Ipazuti fish from Sasquatch Pond. The more we try to remove, the more the cost goes up and it becomes out of control very quickly. That'll do it for number 3 and hence quiz 4.